Imagine waking up one morning and watching the sun rise in the west. Sounds impossible, right? Well, on Venus, that's exactly what happens every single day. The sun rises in the west, crawls across the sky for months, and then sets in the east. The entire planet is moving in a way no other rocky world does. But here's the crazy part. Venus and Earth started with the same size, same mass, the same building blocks. One supports life, the other destroys anything we've ever sent there. And the reason isn't distance from the sun. So why did Earth become this beautiful paradise covered in life, while Venus turned into a toxic hellscape with temperatures hot enough to melt lead? Scientists have spent decades trying to identify the single change that sealed Venus's fate, and what they're discovering could completely change how we search for alien life in the universe. Let me explain. To understand why Venus is so weird, you need to know one rule planets almost never break. About 4.6 billion years ago, our solar system was just a massive cloud of gas and dust floating in space. Then, something triggered it to collapse. Maybe a nearby supernova explosion. And as this cloud collapsed inward, it started spinning faster and faster. Eventually, this spinning cloud flattened into a disk, kind of like pizza dough spreading out when you toss it in the air. The sun formed at the center, and planets started coalescing from the material swirling around it. Here's the key thing to understand. When these planets formed from that spinning disk, they all inherited the same rotation direction, counterclockwise, if you're looking down from above. Mercury spins counterclockwise, Earth spins counterclockwise, Mars, Jupiter, Saturn, Neptune, they all follow the same pattern. This is the fundamental blueprint of our solar system, baked in from the very beginning. But then there's Venus. Venus spins clockwise, going the complete opposite direction from almost everything else. It's like everyone's driving on the right side of the road, and Venus just decides to go the opposite way. So what happened? What could make an entire planet spin backward? To understand what makes a planet do this, you need to see just how far Venus has drifted from anything we'd call normal. It only takes Venus 224.7 Earth days to complete one orbit around the Sun. Think about that for a second. A day on Venus is longer than a year on Venus. If you were standing on Venus watching the sunrise, you could fly a spaceship completely around the Sun and come back before that sun even finished crossing the sky. From one sunrise to the next takes 116.75 Earth days. Can you imagine living on a planet where a single day lasts almost 4 months? Among all the rocky planets, Venus is the only one doing this bizarre cosmic dance. So scientists have been obsessed with figuring out why. And they've come up with two main theories that are both fascinating and terrifying. The first theory is straight out of a disaster movie. Picture Venus early in its history, maybe a few 100 million years after it formed. It's spinning normally, just like all the other planets. Everything's fine. Then suddenly, this massive protoplanet comes hurtling out of deep space. We're talking something possibly the size of Mars, traveling at about 15 kilometers per second. This object slams into Venus with absolutely devastating force. The impact releases enough energy to vaporize continents and melt the entire surface into an ocean of molten rock. The collision is so violent that it either completely stops Venus's rotation and reverses it, or it literally flips the entire planet upside down by more than 180 degrees. Now you might be thinking this sounds like science fiction, but we actually know this type of catastrophic collision is possible because it happened to Earth. About 4.5 billion years ago, Earth got smashed by a Mars-sized object we call Theia. That collision threw so much debris into orbit that it eventually formed our moon. So the moon you see in the night sky exists because Earth got absolutely clobbered by a planetary collision early in its history. The question is, did Venus experience something similar? Computer simulations show it's physically possible. The math works out, and there's actually some compelling evidence. Look at Venus's surface today. It has almost no impact craters. The entire surface appears to be only about 300 to 600 million years old, which is incredibly young for a 4.6 billion year old planet. Something caused a massive resurfacing event that erased Venus's geological history. A giant impact could have triggered planet-wide volcanism that covered everything in fresh lava, And here's another interesting detail. When Earth got hit, we ended up with the Moon. Venus has no moon. Maybe the debris from Venus's impact fell back onto the planet instead of forming a satellite. But here's the problem. There's no smoking gun, no massive impact crater we can point to, no debris field orbiting Venus. Everything is circumstantial. The giant impact theory is compelling, but it's still unproven. The second theory is completely different and just as fantastic. This theory says Venus didn't need a catastrophic collision. Instead, Venus has been slowly doing this to itself for billions of years through its incredibly thick atmosphere. Venus has the densest atmosphere of any rocky planet in our solar system. If you were standing on the surface, you'd experience 92 bars of pressure. That's like being 900 meters underwater on Earth, except you're on solid ground. The atmosphere is 96.5% carbon dioxide, creating this massive, crushing blanket around the entire planet. Now here's why it gets interesting. The sun heats this thick atmosphere unevenly. The day side gets blasted with radiation, while the night side is cooler. This creates these massive thermal tides, basically huge waves of hot and cool air moving around the planet. The sun's gravity also pulls on the atmosphere, creating gravitational tides. These tidal forces act like a brake on the planet's rotation. Imagine trying to spin a basketball while someone keeps pushing against it. Over billions of years, these forces could slow Venus down, stop it completely, and then reverse its direction. We actually have evidence that atmospheric forces on Venus are incredibly powerful. The upper atmosphere exhibits something called superrotation, where winds whip around the planet at speeds far greater than the surface rotates. The atmosphere is literally lapping the planet over and over while the surface barely moves. What makes this theory attractive is that it doesn't require a one-time cosmic accident. It's an ongoing process, happening throughout the planet's lifetime. But the challenge is proving that atmosphere drag alone could reverse an entire planet's spin over billions of years. The timescales are difficult to model, and the conditions would need to be very specific. Now here's where it gets really important, and it's something most people don't realize. This isn't just about which direction a planet spins. This is about whether a planet can support life. Earth rotates once every 24 hours, and that relatively fast spin generates our magnetic field. Deep inside Earth is molten iron that swirls around as the planet rotates, creating electrical currents that generate a powerful magnetic field surrounding our entire planet. This magnetic field acts like an invisible shield, deflecting charged particles from the sun that would otherwise strip away our atmosphere. Without this magnetic field, Earth would be a dead rock. We literally owe our existence to the fact that Earth spins fast enough to create this protection. Now look at Venus. Venus rotates so slowly that it doesn't generate a magnetic field. There's no shield. For billions of years, the solar wind has been sandblasting Venus, ripping away its atmosphere molecule by molecule. Scientists believe Venus actually used to have water, maybe even oceans, but without magnetic protection, all that water vapor got stripped away into space. The slow rotation also creates another problem. On Earth, rapid day-night cycles distribute heat and create weather patterns. On Venus, with days lasting 243 Earth days, heat just accumulates. Combine that with the thick carbon dioxide atmosphere trapping everything, and you get a runaway greenhouse effect. The surface temperature is 464 degrees Celsius. That's hot enough to melt lead. Here's the theory that scientists want to prove. Early Venus might have been habitable. It might have had water, stable temperatures, maybe even conditions for life. But without a magnetic field, without rapid rotation regulating the climate, Venus spiraled into the nightmare we see today. If Venus had just kept spinning faster, everything could have been different. It might have kept its water. It might have avoided the runaway greenhouse effect. It could have become a second Earth instead of a toxic wasteland. This discovery completely changes how we search for life elsewhere in the universe. Astronomers have found thousands of exoplanets, and many look promising. Earth-sized planets in habitable zones where temperatures could allow liquid water. We get excited and imagine alien oceans and extraterrestrial life. But here's what Venus teaches us. Venus is Earth-like by every definition, almost identical size and mass, similar rocky composition. If aliens were observing our solar system from far away, they'd think Venus and Earth were twins. Yet one became paradise, and the other became hell. And the difference might be rotation rate, something we can't easily detect from light years away. A planet could be the perfect size, at the perfect distance, but if it's rotating too slowly or spinning backward, it could end up like Venus. No magnetic field means no atmosphere protection. Slow rotation means poor heat distribution and potential runaway greenhouse effects. This fundamentally changes what Earth-like actually means. We need to understand rotation rates, magnetic fields, atmospheric dynamics. All these factors matter just as much as distance from a star. Venus might not be the exception, it might be the rule. Many exoplanets we're discovering might be more like Venus than Earth. So which theory is correct? Most scientists today think it's probably both. An ancient impact early in Venus's history disrupted its rotation, slowing it down significantly. Then, over billions of years, atmospheric forces pushed it into the backward spin we see today. Venus represents what happens when a planet gets hit by cosmic trauma and never recovers. But we don't know for sure yet. We need better data. NASA's Da Vinci mission will drop a probe through Venus's atmosphere in the coming years. The European Space Agency's Envision will map the surface in unprecedented detail. These missions might finally solve this mystery. But here's what we already know. Earth's 24-hour rotation isn't just a random fact. It's why you exist. Our rotation generates our magnetic field. Our magnetic field protects our atmosphere. Our atmosphere maintains the temperatures where life can thrive. Venus may have had the same starting conditions as Earth, but something went catastrophically wrong. The next time you watch the sun rise in the east, appreciate what you're seeing, because Earth spins the right way. Venus never got that chance, and that's why it rotates differently from every other planet. If this changed how you see our solar system, hit that like button and let me know in the comments. What space mystery should I cover next? Should I explain why Uranus is tilted on its side, or dive into Saturn's bizarre hexagon storm? Subscribe and turn on notifications, because we're exploring the wildest mysteries in space. Thanks for watching, and I'll see you in the next one.